Alright, welcome. This is 7.4, so write that at the top right here. And we got a couple vocab key concepts, so make sure that you are writing down everything inside the box, just like that. As far as the theorem, the if, and everything that's in there, it'd be really helpful. We only got a few of those to do. Alright, so let's go through this really quick. So the first thing we're going to write down is the altitude to the hypotenuse of a right triangle divides the triangle into two triangles that are similar to the original triangle and to each other. So what we're going to do is we're going to have a triangle and we're going to draw an altitude. And so remember, the altitude goes from one vertex and it makes a right angle to the other side of the triangle. So all we're going to do is we're going to draw an altitude and then we split the triangle into two, and then now we can see that we have these two triangles as far as the big one, and we're going to say that all three of these triangles are going to be similar. And remember, to be similar, they are all going to have congruent angles, and the sides are all going to be proportional. Okay, so that's what we're trying to do. We're trying to get to see that all three of these right here are all similar, as far as the little one, the one on the right, and then the one total right there. Okay, so make sure you have everything in there. Our next one that we have right here is corollary 1. So corollary just means something based off a theorem. So it says the length of an altitude to the hypotenuse of a right triangle is the geometric mean of the lengths of the segment of the hypotenuse. Okay, so geometric mean just means that we are going to set up a proportion. So we did this in our previous lesson where we found similar triangles and we found their corresponding sides, and we set up proportions in order to solve. It's the same thing that we're going to do here, even though we draw an altitude. So if we are looking right here, we can see that in this picture down here, we draw an altitude right here on this bottom. Let me get this right here. We're going to draw an altitude right here, and then now we have it separated into two different triangles. So this is also, if it helps for us, this is going to be 90 degrees. And so it might be helpful thinking, like, what is this triangle going to look like right here? Well, if I were to draw this triangle, the smaller one would look like this, where I have 2 and 4 right there. And then this one right here, again, if I were to draw it, let's say I drew it like this, where I have let's say it looks like this. This is the bigger one. There is my right angle. Here is 4, and here is 8. So we got to know the corresponding sides. So this triangle right here, if I would have to flip and turn it, so it would look like this right here. This would be a better way for me to draw it, with 4 right here and 8. I have the smaller leg and the bigger leg, and so now I have the corresponding sides, and now I can set up a proportion. So the proportion, one way to write it is I could have 2 over 4, so I have the bottoms 2 over 4 equals, and then I have the other sides of the leg 4 and 8. So really useful to be able to know how the triangle, which part goes with which part. Okay, so it might help drawing two separate ones if that is helpful for you. And then, so make sure you have everything written down there. And then our last one that we have is the same thing. It just says the altitude to the hypotenuse of a right triangle separates the hypotenuse. So the leg of each triangle is the geometric mean. Okay, so all this means, though, this big thing, all it means is that we can take the bigger triangle still. So we are taking 4 right there, and we are comparing it to now the smaller triangle right there. So if I were to separate this into two, what this would look like is, again, this makes a 90-degree angle, and so I have my smaller triangle looks like this, with my right angle, and I have 1, and my hypotenuse is 2. Remember, the hypotenuse is diagonal from the right angle. And then I have this right here, where I have my big triangle. I'll draw it the same way right here. Here's my right angle. I see that across from the right angle is 4, and my leg is going to be 2 right there. So now I can do the same thing as far as set up a proportion, just with the total big triangle and then one of the smaller triangles. And I can set it up to get 4 over 2 equals 2 over 1, and I can see that those triangles' sides are proportional. Okay. All right. So let's get into a few problems now. Alright, so our problem number 1, make sure to write out the prompt, which says, what similarity statement can you write relating the 3 triangles in the diagram? So we have, here is our triangle, and it's split with altitude, and so we can see that we have our large triangle right here is right there. That's a big one that we can see. We have another one that is split right here, and then we have a third one that looks right there. So there are my 3 triangles. You don't need to do those extra lines, but now we can see the 3 that we have, and we need to write a similarity statement. Okay. So what is useful, and I think this can help me do it, show a little bit similar, is if we can, let's see if I can get it, we have our big triangle right there, and if we can draw all these triangles kind of facing the same way, it might be a little bit easier for us to write this similarity statement. So there is my big triangle right there with x, y, and z. The next one is I'm trying to find this larger one inside of it. So if I were to write it, and you see how I have the right angle right there, but I want to make all these triangles face the same way so it's easier for me. So you see how this kind of just flips it until, boom, that they are facing the same direction. As far as my right angle is right there, and I see I have my hypotenuse across, so those match up. And then my last one, I need to find this blue one right here. And again, I need to make sure that I have the right angle. And remember, when you have an altitude right there, it splits it into 90 degrees. And so when I have it down here, I just need to make sure I get it facing the same way. And so now that I have these 3 different triangles, it makes it a lot easier to write a similarity statement. So my similarity statement would be right here. I have triangle XYZ. And then I have to have them match, be in the same spots. And remember, we do that little squiggly line right there. So it's going to be similar to triangle YWZ and similar to triangle XWY. Okay? So make sure that you have like these 3 written down. I think that would be very helpful. And this would be my final answer right there. Cool. All right. Alright, so here we go. Our next question, it says, what are the values of x and y? So this question is going to look very similar to what's going to be on your test. So again, we are going to set up a proportion. And we need to know what we are looking for right here. So let's see. It's first going to be very useful if we label these different sides. So we're going to use our corollary 2, that was the second one that we wrote down, in order to solve. But now I have, if I label just each of these sides that I have right here, it's going to make it a little bit easier for me though. Okay, so I am looking at this right here, and I have to start set up a proportion, and I am solving for x. So if I'm looking at x right here, I know if I were just to draw this down, here is, this also makes a right angle, and when it is a cross, just like that, that means that x is my hypotenuse. So I'm trying to find the hypotenuse of it, and so I'm trying to find that right there. I don't know, here is the other smaller triangle inside of BCD. Well, I don't know what that hypotenuse is, so I can't use that smaller one, but I can look at just the bigger triangle that I have right here. So I have this big triangle right here. Well, that was terrible. And I see that I have a right angle right here, which means that that this right here, AD, is the hypotenuse. Okay? So I am going to use those 2, and I can see that it's built up of 12 and 4, so I know that that hypotenuse right there is going to be 16. So I'm going to be using that, the big triangle as a whole, and then the small triangle. And I'm going to be setting up a proportion. Okay? So when I am doing this, the first thing I'm going to do is just like what we said right here. we're going to find the lengths of the two hypotenuse, which is going to be AB, which we said that's the hypotenuse of the big triangle, and AC, that's the hypotenuse of the small triangle, and we're going to put that over one of the legs. And we know that there is always like a short leg and a longer leg, and the two legs that we have are we have AC. We have AC right here. That is one of the shorter legs of that big triangle, and over AD. AD again would be that one. So again, if it is helpful, you could always, if you wanted to, if you're trying to just visualize, it's hard for you to separate it, you could always draw like that big triangle, and that was terrible, of A, B, C. Here's that big triangle, and then I could draw this little triangle that I have right here, and then I know if I have my little triangle that looks like that, I have my right angle, and I have D, this is going to be C and A. I could always draw it right there if it makes it a little bit easier for me to be able to visualize, separate the two, but if you can see it, that would be useful as well. So now that I have this proportion, all I'm going to do is I'm going to plug in the numbers for each one. Okay, so I'm going to write down, you're going to write down this right here. So I have this proportion. The hypotenuse of AB is 4 plus 12 over x, and we have on the other side we have x over 4. Okay, and then so next, when I multiply, when I add these two together, I get 16. 16 times 4 is 64, and when I take x times x, I am going to get x squared. Okay. And so the last thing I have to do, I want to just figure out what x is, not x squared. So I would have to take the square root of both sides. And when I take the square root of both sides, I get, usually when I take the square root, I get a positive 8 and a negative 8. But since we're talking about distance, we're only going to be dealing with positive. So my answer would be x equals 8 right there. Okay, so I have x equals 8. So make sure you have that all written down, and then my next step is I also want to know what y is. So to solve for y, again, first I'm going to set up my proportion. So I am going to have, I got to make sure that they are matching up. So I have AD and CD. So I have the two small legs that I have right there. And then I'm going to set the equal to CD and DB, sorry. Okay, so I have those set up. Again, if you need to separate those triangles into two to be able to figure out which side matches up with which side, that might be helpful, but I just have to know that the small leg goes with the small leg, the hypotenuse goes with the hypotenuse, which one matches up. I know the hypotenuse is always the one across from the right angle. That's an easy way to be able to tell. And how do I know if it's a small leg or a larger leg? Obviously the smaller number is the smaller leg. Okay, so if I have that set up, all I'm going to do now is plug in these numbers that I have right there. I'm going to fill them in. So I get 4 over y equals y over 12. I'm going to do cross products, which y times y is y squared. 4 times 12 is going to give me 48. So again, I want to know just what y is, not y squared, so I need to take the square root. So I'm going to take the square root, and 48 is not a perfect square root, so I need to simplify. So the way I'm going to do is I'm going to think about what numbers can I multiply to get to 48, and we know that 48, that 6 times 3 is 48, so I'm just kind of playing around with numbers. So like these are still under my square root when I'm simplifying, kind of a review a little bit of last year. And then what I can do now is that 16 times 3 is 48, so it's the same thing, I'm just splitting it up. But the reason I am doing that though is because I can now separate these two into square roots. So again, I have, these are just multiplying together. 16 times 3 is the square root of 48. But we know that 16 square root of 16 is a perfect square root. So when I simplify out that's going to give me 4 square root 3. So my final answer would be x equals 8 and y equals 4 square root 3. Okay? Alright, perfect. Thanks for watching, guys. See you soon.